Good afternoon, everyone. Thanks for Huobi and Loy's invitation. I'm Yaoqi, the head of technology and co-founder from Zilliqa. And today, I'm going to share some of my knowledge on these scaling blockchains. So first, I want to do a quick survey. So apart from this wallet and also the exchanges, how many of you use some other blockchain-based application? Please raise your hand. Okay, I see. Thanks. Basically, very few of you have used this blockchain-based application. And this is a common scenario in this current blockchain space or in the cryptocurrency space. Basically, very few interesting decentralized applications are existing in this space. And last year, there's a phenomenon application called CryptoKitty. As you can see, it is very famous and popular during the November and December last year. And the concept is very interesting. So basically, the users and also the geeks, they can raise the very cute cats, the digital cats. And if they collect a couple of cats, they can give birth of a new cute kitty. And at the same time, since you can trade these cute kitties on blockchain, basically Ethereum, and then you can earn some ethers from these crypto kitties. And as you can see, for this very cute and small kitty, you can earn over 100,000 US dollars at that time. And for these amazing applications, people are realizing that, so basically we can build decentralized applications on top of blockchains and we can have fun on it. At the same time, we can also make money from it. However, since this application was super popular at that time and so many people are willing to buy these kitties and they will send these high gas fees to compete with the other users to buy these cute kitties. Then at that time, as you can see, the gas fee for one transaction on Ethereum blockchain, it was increased by over 39 times. And if you are a normal user and you want to send one ETH to another user, then you have to pay a super high gas fee because you have to compete with the other users, especially these CryptoKitty users. And then, so the CryptoKitty team are thinking about how to resolve this issue. So basically, due to the network congestion, they have to double this birthing fee. At the same time, they are also seeking for these long-term solutions to support these CryptoKitty users. And then you can see this is the main topic of or the main issues of our existing blockchains. The main reason that for the existing blockchains, mostly for the most famous ones like Bitcoin and Ethereum, they have this relatively low throughput. For example, Bitcoin has 7 transactions per second and Ethereum has less than 20 transactions per second. This is not that, it's not that these blockchains are not good, they are super good. And for myself, actually, I was amazed by the Nakamoto consensus from Bitcoin. It is the first time I can see that basically scalable blockchain can support over 20,000 nodes in the network and across the world can run the consensus protocol smoothly. And as you can see, at the beginning in 2009, the first Genesis block was mined in Bitcoin, and until now, it's around 9 years. And there's no big issue about this great consensus protocol and this Bitcoin system. However, everything is nothing is perfect. And compared to this traditional ledger, for example, the Visa and the MasterCard, which can process over 8,000 transactions per second, these existing blockchains actually they have this drawback, which can only process very low TPS. And for distributed ledgers, it is maybe okay, but in the future, as we can see, we want to support more decentralized applications. Maybe we need more improvement for these existing blockchains. Then what are the existing solutions? And the first solution, maybe you can think is about this increasing the block size. For example, Bitcoin has the block with the size of 1 megabyte, and last year for the Bitcoin Segway 2x, they want to increase the block size from 1 megabyte to megabyte to double this TPS. However, you can double the block size and double the TPS, but you cannot increase this 1 megabyte block size into 1 gigabyte block size. So it is not 100 scaling factor. The root cause is that basically our laptops and even these manual machines, they have the limitation of the storage and also these bandwidth. So for Bitcoin, they need one block within 10 minutes, and at the same time, the miners need to broadcast this block properly to the whole network. However, if you increase it to 1 gigabyte, and it requires miners to process more transactions for one block time. At the same time, it's super difficult for 1 gigabyte block to be broadcast to the network within 10 minutes properly. And due to some reasons, basically, as you can see last year in November, the Bitcoin Core finally canceled this hard fork of the Segway 2x. There is another interesting approach called off-chain transaction solutions. So basically, this idea or this concept wants to ensure that a lot of transactions can be processed off-chain instead of you directly put it on-chain. For example, I'm running this gas station, and there are some drivers, they want to pay this money to my gas station via this blockchain. Instead of these drivers directly put these various transactions on-chain, actually they can first send one transaction on-chain and deposit some money, and later they can send a bunch of transactions to my gas station's server. And after 2 weeks or even 1 month, my gas station basically can set a settlement transaction on-chain. So in this way, instead of sending like over 20 or even more transactions to the main chain, my gas station actually can help to reduce the number of transactions to 2. The good part that basically my gas station can have a very powerful server and support like 100,000 TPS. However, there are also some major issues. For example, since I'm running the whole systems off-chain, and there's no transparency and decentralization existing there. And basically, if we are using this approach, we lose some of these good properties from the blockchain. And the third solution basically is about these delegated protocols. As you can see, in Bitcoin or Ethereum, we have over 20,000 miners or over 20,000 nodes. Instead of we ask everyone to run the Nakamoto consensus protocol, maybe we first vote some of them as the representatives. For example, we can form a group of 7 or 21 or even 100 nodes, and then within this small group of nodes, they can run the consensus protocol and quickly generate the block representing the whole network. So the good thing that, as you can see, in distributed system, fewer nodes within one group, they can faster generate the consensus result. And then with fewer nodes, you can produce a block in a faster manner. However, the issue is also about this small group of nodes. Most of the protocols actually they are based on of this proof of stake or even based on proof of some other wealth. in this way, the community members or even these nodes in the network, they may have doubts that maybe these 100 nodes, they cannot represent them because they only represent their own money. Here I want to say that basically for the existing solutions to improve the throughput of the blockchains, there's no one approach is the best or is the worst. So basically they are customized for different scenarios. For example, the off-chain solution basically I think is perfect fine for some payment services. For example, if you run a coffee shop or this gas station example, it's very good for you to run this off-chain solution, and finally you can aggregate all the transactions to generate a settlement transaction per on-chain. Here, Zilliqa, we are trying to use another technology to scale the existing blockchain. The secret recipe for Zilliqa is about sharding. Later I will briefly explain what's the sharding. And here you just look at the figures and also the numbers. From 1,100 nodes, and we grow this number into 3,600 nodes. Basically, our throughput can increase to 2,400 transactions per second. And at the same time, you can see the beauty of Zilliqa that we can increase the TPS with the network size increase. This is not a new approach. Basically, since 2015, our team has been working on it for some time, and we published the paper on one of the top security conferences called the CCS 2016. And as you can see, Loy and also my advisor, Perdi Saxena, they wrote this paper. And it is the first research paper talking about how to implement sharding technology for public blockchain. And so what's sharding? So for Zilliqa, we are implementing two concepts of sharding. One is the network sharding, and the second is the transaction sharding. So the network sharding means that suppose we have a network with over 20,000 nodes, then we can divide these 20,000 nodes into different group of nodes, and later we call this group of nodes as shards, and they can process the transactions individually and in parallel. So at the beginning, we divide the whole network into different shards, but gradually some old nodes want to leave the system, and also some new nodes want to join the system because it's quite profitable. So how can we handle it? Then periodically, our Zilliqa system actually can allow this new node to join this system. The mechanism is based on proof of work. Basically, all the nodes in the network, they will run this proof of work algorithm. Right now, it's Ethash, same as Ethereum. And after they figure out the results of the proof of work, basically they can have the entrance tickets to enter the network and to run the consensus protocol. Later will be rewarded by ZIL tokens. And with the last several bits of the proof of work results, we randomly assign these nodes into different shards. So in this way, we can prevent the adversarial nodes to target one specific shard. And after that, as you can see, we divide the whole network into different regions. And then for different shards, they can process the transactions in parallel. Then it's about how we can distribute the transactions into different shards in a secure manner. So here we have a smart trick. So basically, we ask all the nodes to send the transactions based on their senders' addresses. In this way, all the nodes within one shard, they will basically check all the transactions sender addresses. If the sender address is not belonging to the shard, the nodes will reject this transaction and they will decline to process this transaction. So in this way, we can smoothly to prevent double spend attacks. At the same time, after processing these transactions and generate this set of valid transactions, within one shard. All the nodes within that shard have to run consensus protocols to agree on the same set of shards, same set of transactions. So what kind of consensus protocol we are using? Here we are using a different consensus protocol from this Nakamoto consensus protocol used in Bitcoin and Ethereum. That is this practical Byzantine fault tolerance, which was proposed by Prof. Barbara from MIT in last century. So with this consensus protocol, we can achieve immediate finality of the blocks. At the same time, we can also have this energy saving system. And further, we also employ this collective signing to further reduce the message complexity of the consensus protocol. Plus, we apply some security mechanisms on the consensus protocol. We can achieve a relatively high throughput of our Zilliqa consensus protocol. So basically, we apply sharding plus our new consensus protocol, we can achieve this high TPS. And further, since we can process transactions in parallel across different shards, and then we can scale the throughput with the increase of the network size. Since 2015, some of our team members, they founded a company and working on this private blockchain using sharding technology. And they collaborate with some Singapore exchanges and also some e-commerce companies to apply these private blockchains for their applications. And with Zilliqa, basically, apart from achieving this high TPS, we can also have this relatively miner-friendly system. And since we have this high TPS, the users don't need to compete with the other users to write their transactions into a blockchain, so they have these relatively low gas fees or transaction fees. And at the same time, we also provide this safer and efficient smart contract language. Later, I will explain you more. So right now, we already published our first testnet, and you can basically register your addresses via this wallet URL. And you can also claim some test tokens to test out our testnet. This is the URL for our first public testnet, and you can try out using our test tokens. Here, I also want to show you some results from our latest testnet. Last night, we hosted our major meetup in Singapore, and we show a lot of demos of our latest testnet and also our new smart contract language. As you can see here, the baseline is one shard has 200 nodes, and with one shard we can achieve around 400 transactions per second. And once we increase the shard number into 2, we double the TPS. And how about we have 4 shards? We can have around 2,000 transactions per second, and with 6 shards we can achieve 2,800 transactions per second. Here, the number is not the important part. The most important part, as you can see, with the increase of the network size, we can have this linear scalability. So basically, talk is cheap, but experiments are super expensive. Within our team, we sort of run multiple testnets in parallel, and we have used up a lot of instances for different regions like Singapore. Here, the red dots and the other colors dots basically are the instances we use for our testnet. As you can see, Zilliqa is quite different from some other ICU projects. Basically, we really run the large-scale testing for our testnet, and in future, we will also show our mainnet with this large-scale. So at the same time, we also provide this new secure smart contract language called Sila. It's automata-based, basically can help developers to clearly implement their logic using these states and also state transition. At the same time, we also provide these templates and maybe also these framework for the developers to generate these formal proofs of their smart contracts. Here is some sneak preview of our smart contract dev GUI. It's similar to Remix. Basically, you can deploy your smart contract at the same time. On the left side, you can see the transaction is generated, and you will have the smart contract you want. At the same time, you can get the results from the smart contract. Further, here is some proof from this formal proof tool called Cork. And later, we will release some of these Kickstarter smart contracts and also the templates for the formal proofs. So as a developer, you can easily deploy your Kickstarter smart contract. At the same time, you just need to modify a few lines of code. You can have a better formal proof of your smart contract. And for us, Zilliqa is a little bit different because most of our team members are from academia, and most of our members are from this National University of Singapore. And we are focusing more on the research and the engineering of some state-of-art blockchain technology. And right now, we already collaborated with some partners like Mindshare on the digital advertising, decentralized application. At the same time, we are also working with Genaro and Bluezeo on the decentralized storage management. In the future, we are always willing to collaborate with other teams and especially institutions to figure out some these open research problems and also the answers to these problems. So recently, some people have thoughts about Zilliqa, saying that we are not doing sharding. Here, I just want to clarify that. We've been done a lot of things about sharding, and in the future, we will do all the things about sharding, especially smart contract sharding. So this is all about my presentation, and thank you.